Hi everyone, this is Kamal. Welcome to my channel Understand Tech here. If you are looking to know all the practical things about RAM, this is the video for you. It discusses what is it, types, where is it inside our computer, what it looks like, what its functions or why do you need it, how the performance of computer is affected by the amount of RAM available, its relations with virtual memory, how much do you need it, how do you add or upgrade extra RAM. Everything is explained in a step-by-step manner with animated diagrams. So please stay tuned. Before we discuss what RAM is, what's its role in computer, let's first discuss where is it in our computer and what it physically looks like. This is a computer with its different parts. Now, this part is a system unit box. If you open this system unit box, that's what you see. As you can see, most of the important parts of computer are here. This is where you find this part called RAM. Let me enlarge this part. As you can see, there are two places or slots to keep RAM. So this is what RAM looks like physically. So what's a RAM? RAM stands for Random Access Memory. It's a volatile memory that provides CPU of fast access to data and instructions. RAM are actually of two types: DRAM, Dynamic Random Access Memory, and SRAM, Static Random Access Memory. Though SRAM provides a faster access to data and instructions than DRAM, but it is more expensive at the same time. Therefore, RAMs used in computer are DRAMs. DRAMs are made up of capacitors. Okay, you saw where RAM is and what it looks like. Still, before we can discuss what's its role in a computer, why you need RAM, you need to have the concept of software. First things you have to understand is a computer does not do anything in its own. Of course, a computer is not a living creature that has its own brain, that it can think and do things in its own. There should be written commands in a computer. So whatever we see happening in a computer, those things are happening according to commands in a computer. Or whatever we say computer is doing, it is doing things just following those commands. And collections of such commands is software. Okay, let's say you started a Microsoft Word by clicking on a certain screen appears. Think about this. How does a computer know to show this kind of screen when you start Microsoft Word? A computer does not know what screen to show. There are commands to tell a computer what kind of screen to show when you start Microsoft Word. Let's say you type something. On checking spelling, computer is showing that there is a spelling mistake. Now think again, how does a computer know this spelling is incorrect? there are commands which tell computer which spelling are incorrect and which are correct. So when you say you have Microsoft Word in a computer, it means you have commands in your computer which operates Microsoft Word. Therefore, when you say you have certain software in a computer, it means you have commands to operate that software. Does this statement make sense to you? When you say you have a certain software in a computer, it means you have commands to operate that software. All software in computer are generally in hard disks. Let's say you have Word, Excel, Chrome in hard disks. As we said earlier, when you say Word, Excel and Chrome are in hard disks, it means commands that operate Word, Excel, Chrome are in hard disks. Let's say you want to use Word. When you try to start Word, commands that operate Word are brought to memory. Now, CPU gets command one by one from memory. And it starts to take action as commands say. Note, when you close Word, all commands to operate words are removed from memory. Why commands have to go to RAM and CPU get commands from RAM? Right? Why commands have to go to RAM and CPU get commands from RAM? Why CPU does not directly get commands from hard disk itself, like shown here? Let's do a small math here. Before that, I want to make it clear that I have simplified things to a great deal here. In reality, of course, things works in a much more complex manner than I have described here. Let's assume it takes 100 nanoseconds for commands to reach RAM from hard disks. And let's assume it takes 10 nanoseconds for commands to reach from RAM to CPU. CPU is an extremely fast device. Let's assume it takes 1 nanosecond to carry out tasks as specified by commands. Similarly, let's assume it takes 100 nanoseconds for commands to reach CPU from hard disks. With these assumptions, let's try to find out how much time does it takes to complete 3 commands if CPU has to get commands from RAM. So in case of getting commands from RAM, time to reach 3 commands from RAM to hard disks, 100 nanoseconds. Time to reach first commands from RAM to CPU, 10 nanoseconds. Time to carry out first commands by CPU, 1 nanosecond. Time to reach second commands from RAM to CPU, 10 nanoseconds. Time to carry out second command by CPU, 1 nanosecond. Time to reach third command from RAM to CPU, 10 nanoseconds. Time to carry out third command by CPU, 100 nanosecond. So, total time to complete 3 tasks, 133 nanoseconds. Now let's see how much time it takes to carry out 3 commands if CPU is to directly get commands from hard disks. In case of getting commands from hard disks, time to reach first commands from hard disk to CPU, 100 nanoseconds. Time to carry out first commands by CPU, 1 nanoseconds. Time to reach second command from hard disk to CPU, 100 nanoseconds. Time to carry out second command by CPU, 1 nanosecond. Time to reach third commands from hard disk to CPU, 100 nanosecond, and time to carry out third command by CPU, 1 nanosecond. So, total time to complete 3 tasks, 303 nanoseconds. As you can see, it takes much longer time to carry out commands if CPU has to directly get commands from hard disks. It is because of this reason commands or software are brought to RAM from hard disks. We just discussed why it is not a good idea to get command directly from hard disks. Since it is not a good idea to get commands directly from hard disks, commands go from hard disk to RAM, and CPU get commands from RAM. You might be thinking, well, if it is better to get commands from RAM, why not keep all commands to operate different software in RAM in the first place? So why not keep all commands in the RAM in the first place? Why keep in hard disks? If for any reasons computer shuts down, everything that is in RAM is lost. So in order to keep things permanently, you need hard disks. So you can see hard disks and RAM balance out each other weaknesses. Hard disks can keep things permanently, but it takes long time to get things from hard disks. While on the other hand, it is quicker to get things from RAM, but it cannot keep things permanently. That means we need both hard disks and RAM in our computer. So far, I have been saying whatever software you start, commands to operate them go from hard disk to RAM. However, not only commands of currently used software is in RAM, but anything that are open will be in RAM. If you are viewing web pages, it will be in RAM. There is document in a pen drive. If you open it, documents from pen drive go to memory. In fact, you can very easily see what software and documents have occupied how much space of RAM. For this, go to search bar and type Task Manager. You can see what software has occupied what amount of memory. We said commands to operate software comes to RAM. If that's the case, on starting some software, say Google Chrome, amount of RAM used should increase, right? So let's see whether that happens. Now you can see 61% of my RAM is occupied. The amount of RAM used here is shown in graph. Now I am starting Google Chrome. As you can see, when I started Google Chrome, the amount of RAM used has increased. That means definitely commands to operate Google Chrome has come to RAM. Also, we said If we close any software, commands to operate that software will be removed from RAM. Hence, if I close Google Chrome, the usage of RAM should also decrease, isn't it? Let's see whether that happens. Now I'm closing Google Chrome. So as you can see, the amount of RAM used has decreased. What happens if RAM is small and not everything you open can fit in RAM? Let's say this much RAM is occupied by other software and documents. Let's say you want to start Google Chrome. As we said, any software or documents you open go to RAM. So when we start Google Chrome, commands to operate Chrome go to RAM. However, as you can see, there is not enough space in RAM. So commands to operate Chrome can't go to RAM. A part of hard disk is reserved, and so when we start Google Chrome, commands to operate Chrome go to this reserved part of hard disk. This part of hard disk reserved for such purpose is called virtual memory. However, there is one big downside of this mechanism. Now, commands to operate Chrome has to go to CPU from virtual memory, which is actually part of hard disk. But we have explained earlier, it takes longer time to reach things from hard disk to CPU. So if any things are running from virtual memory, those things are going to run slowly. In comparisons to this, if commands would have been in RAM, commands would have quickly reached CPU and things would have run quickly. I would like to add here, the management of virtual memory is more complex than what I have shown here. For example, it involves swapping in and out data and many other things. So how much RAM do you need? First thing is, you want to have sufficient RAM so that all software and documents you open can fit in RAM. If the capacity of your RAM is small and not everything can fit in RAM, and some of the things have to go to virtual memory, as we just explained, this will result in your computer operating slowly. But at the same time, having just too much extra RAM also does not result in an extra better performance. Let's say if everything fits in 4 GB RAM, then having 8 GB RAM is not going to result in any better performance. The amount of RAM you need depends upon the types of operating system and software you use. For example, if you use Windows 7, 2 GB RAM may be sufficient, at least for normal use. But if you use Windows 10, 2 GB RAM is not going to be sufficient. Generally, 4 GB RAM is recommended. However, if you use software like video editing software with 3D rendering capability, then even 4 GB RAM will not be sufficient. You might generally want to have some extra RAM in your computer than you currently need. Let's say you purchase a laptop having 4 GB RAM and it could be sufficient for your current need, but in future you might want to use, we mentioned earlier, video editing software with 3D rendering capability. Then 4 GB RAM is not going to be sufficient. So if such is the case, you might want to purchase computer with 8 or more GB RAM. Having said this, you can always add extra RAM later on. When purchasing a new RAM, make sure you mention model number of your motherboard to a person's in a computer store, because types of motherboard and types of RAM should match. How's today's video? Please leave your comments and suggestions below. I'll be posting videos like this which explain fundamental computer concepts in a way even non-technical person can easily understand. So please do consider subscribing to my channel. So this was for today. Thank you so much for watching this video. See you in next one.